Hello, seekers of truth, and welcome to the continuing lesson on the derivative of natural log. So, from the last discussion, we ended on this point that the derivative of natural log of x is actually 1 over x. Okay. And so one more thing that we can extract from this is that the indefinite integral of 1 over x dx is then equal to the natural log of x plus a constant. And so this is just using the fact that we have an antiderivative. Now, if you aren't quite convinced of this, try to apply, the power rule of derivatives or antiderivatives to this and see what would happen there. But if the derivative of natural log is 1 over x, then that can only mean that the antiderivative of 1 over x is the natural log of x. And just so that you see a little bit of why this is true, so if I have a graph of the natural log of x here, okay, this is f of x equals the natural log of x. Sorry, it's this is a little bit misleading. It actually goes up this way and continues on forever. It's not. Now, this has a domain of x greater than 0, because you can't take the natural log of 0 and you cannot take the natural log of a negative number. And if you notice here, this is increasing. This is always increasing, and concave down. Okay. So that means this implies that f prime is always positive, it's optimistic, it's always positive, and decreasing since f is concave down. Okay. And if we study the 1 over x function, this is 1 over x for x greater than 0, okay? It matches this description. Now there's another part here, okay? The 1 over x function has another part here, but it doesn't really apply when we talk about the derivative of natural log, because natural log is only defined for positive numbers. So graphically it makes sense. There's some intuition behind it, and the work that we did in the previous video confirms that. So we can actually continue and see another very important result. So now we're going to find the derivative of e to the x using implicit differentiation. Now there are other proofs of the derivative of e to the x, but since we've already done a lot of the work for natural log, I'm going to take advantage of that. Okay? So I'm going to start with an equation that we know to be true, that the natural log of e to the x is equal to x. Okay? So the natural log of e to the x is equal to x. Okay, this is known fact. Known fact by the property of the power rule of logarithms. So then let's take the derivative of both sides. So now let's take the derivative of the left-hand side and the derivative of the right-hand side with respect to x. So in the right-hand side, that's simple enough. That's just 1. The derivative of x is just 1. Over here, right, so we have a chain rule situation. So we have the derivative of natural log of this function here. So we already know that the derivative of natural log is 1 over x. So in this case, it's 1 over e to the x. Okay, so remember, this is chain rule now. Chain rule is what's applying here. Okay, so that's the derivative of the outside function times the derivative with respect to x of the inside function, e to the x. Okay. So the derivative of natural log is 1 over some function, in this case e to the x, times the derivative of the inside function. So this is the equation that we have, but if we multiply both sides by e to the x, this expression goes away because that's just 1. So then that tells us that the derivative of e to the x is equal to e to the x. And so this is truly amazing because it says that e to the x is its own derivative. It is its own derivative. This warrants a star, maybe 2 stars, because that's kind of a big deal. Okay? So we have a function here where its derivative is itself. All right, so let's let it soak in for a minute, and then continue to play the video, and we'll see what some of the implications are for this. Okay? So knowing this fact, what this then tells us is that the antiderivative of e to the x dx is also equal to e to the x plus a constant. And if we look at a graphical interpretation of this, this is quite amazing. F of x is equal to e to the x, so f prime of x is equal to e to the x, and f double prime of x is also equal to e to the x, and f triple prime of x is also equal to e to the x. And if you look at this graph here, this is, let's see, increasing. It is always increasing and concave up. Okay, always. So that means its derivative, f prime, must be positive always and increasing. Okay. And incidentally, it's the same picture again. So f prime is the exact same picture. And one other thing to note here is, let's say you have a point here, k, and this point here, the height of this here is f of k, and we try to look for the slope of k, of f of x at k, so this slope here, right? So what we know, from what we know about e to the x, is the slope at this point is equal to the y value at that point. Okay, so we can say that f prime of k, in other words the slope here, is in fact equal to just f of k for this particular special function e to the x. Okay. Well, I am going to end this right here, and hopefully you were able to follow this logic. As always, if you have a hard time, ask your teacher. And it's essential, it is absolutely essential that you are able to internalize the reasoning behind why e to the x is its own derivative and the implications for that, as well as why the derivative of natural log is actually 1 over x, and able to recognize some of the implications behind that. Thank you for watching. Have a wonderful day.